So let's write a program that does prime factorization for TI graphing calculators. Why? Well, because here's a $10 Casio scientific calculator that can do prime factorization of a number. But here's a $120 fancy TI graphing calculator with a color screen, and it cannot do prime factorization. So I'm going to show you some code that's going to work even on an older TI-83 right here, so you can follow along at home. We're going to put the code right here. And for those following along on the TI-86, I'm also going to give you the code right here, so you can pause the video and follow along. Let's go to program factor. We prompt the user for a number n. We do some basic checking. We want n to be a positive integer greater than 0. So we yell at the user if he enters an invalid value and stop the program. Otherwise, we keep going. We initialize our list L1. That's a built-in list variable right here, L1. That's not the same as the letter L, the number 1. And we initialize S, which is going to keep track of our place in the list. And the first thing we do is check how many times our number n is divisible by 2. So this is a loop that runs until n is no longer divisible by 2. And this is the same as checking if the fractional part of n over 2 equals 0. I'm just using a not operator because it's faster than checking if it equals 0. So if it is, we add 2 to our list of factors. We increment s, and we divide n by 2. And that's going to run until it's not divisible by 2 anymore. So then we set the square root of n as our new maximum value that we want to search, and 3 as our new factor. And we run a second loop while a factor f is less than the maximum. And we have a nested loop inside of it that's going to check if our value n is divisible by our factor f. If it is, we divide it by f and store it as the new n. We add f to the list of factors, and we increment s by 1. And we set the square root of the new value of n as our maximum value that we want to search for. And otherwise, we keep repeating the loop and incrementing f by 2. So we're only interested in odd numbers at this point because we already checked for divisibility by 2. And run that loop to the end. And if we reach this point and n is still greater than 2, then we also add n to our list of factors, or if n was itself initially a prime number, then we also add that to the list. And we simply display the list out to the user. So let's demonstrate how that works. Program factor, and let's say we do 1, 2, 3, and there's a list of factors. So let's try something else. So we'll check the Casio. Let's say 1, 2, 3, 4, 5. Factor that. Should be this answer. So let's try it. 1, 2, 3, 4, 5, and there's our answer right here. Now the only thing it doesn't do is keep track of repeating exponents. So for example, if you have 32, well, the prime factor of that is 2 to the 5th power. Whereas our program is just going to spit out the number 2 5 times. And yeah, there's a way you can modify the code to keep track of exponents and display them separately, but I want to keep it short and simple, so yeah, there you go. So that's basically it. If you like the video, be sure to like, comment, subscribe, all the good stuff, and we'll catch you next time.